Good day, guys. Good day. Welcome back to Math Chem tutorial. Yes, today we are going to look at organic chemistry. The particular aspect we are going to focus in this organic chemistry is the structural isomerism. Before I start, now let me remind you of what isomerism is all about. Isomerism is just all about the appearance of two or more organic compounds in which they have the same molecular formula but they have different structural formula. What does that mean? It simply means that isomerism is when you have a molecular formula. For an instance, this particular C5H12. So whereby this C5H12 can be written in so many pictures. Let me explain it like that. In so many picture. When I'm talking about picture, I mean the structural formula. So the particular example we are going to look at today is determine the isomers of pentane. Determine the isomers of pentane. Don't forget that pentane is from alkane group. So the molecular formula for pentane is C5H12. C5H12. So we are to look at the isomers of pentane. That means how many pictures can we draw pentane into? So how many pictures can pentane appear? How many structure can pentane appear? Now don't forget that pentane, it has the suffix of what? Ane. Yes, pent, 5. Ane means from alkane group. So pentane, all alkane group, they have what? A single bond. They have a single bond. So please take note of that. Now, how do we start? There are some protocols you need to follow in isomerism. To determine the isomer of an organic compound is very simple, especially when it comes to the aliphatic compound, such as those of alkane, alkene, alkyne, and others. So how can we determine the isomers of pentane in which the molecular formula is C5H12? The first thing to do is for me to draw the picture of pentane itself, the structure of pentane itself. When I'm trying to picture, I'm trying to refer to structure. So please take note of my words. The structure of pentane is C, 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 C. Don't forget that pentane has 5 carbon atom with what? 12 hydrogen atom. So the picture or the structure of pentane goes thus. Yes. This is the structure of what? Of pentane. Which I can still write it as what? CH3, CH2, 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 and what? CH3. As you can see, this is what? CH3. Okay, this bond here. I'm just trying to simplify this into this. So this is CH2, this is CH2, CH2, and CH3. And CH3. Perhaps you might not put the bond, and if you like, you can put the bond. The bond doesn't mean anything. So this picture, this structure itself is what? Pentane, because it has 5 carbon atom of 1, 2, 3, 4, 5, and what? 12 hydrogen atom of 3, 5, 7, 9, and 12. And what? 12. So this structure itself, it is what? It is a look of what? Of pentane itself. So this is the first isomer for pentane. That is the first isomer of what? Of pentane. Now, let us now look at the second isomer now. There is something you have to take note in isomer, in determining isomer of an organic compound. Firstly, draw the compound, draw the structure of that particular compound you are given, as you have done here. This is, you are given pentane, you have to determine the isomer or the isomers of what? Pentane. And this is the diagram of pentane. This is the structure of pentane, which will be our first isomer. If you are given hexane, anything, butane, propane, and others, if you are given to determine the isomer of that particular compound, probably hexane, for an instance, the first thing for you to do first is for you to draw the structure of that hexane, which it can be like this and it can also be like this. And even you can also write it as CH3, CH2, 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 CH3 without you putting the bond. You are still writing the same thing. Now, the next thing for you to do in order to determine the second isomer of pentane is let me say for me, to what? To reduce the number of carbon atom to 4. To reduce the number of carbon atom to 4. Don't forget that pentane has 5 carbon atom. It has 5 carbon atom. So, but for me to know which structure can I still draw this pentane is for me to what? To reduce the number of carbon to 4. Don't forget that it's going to remain 1 carbon out, such as 1, 2, 3, 4. Can you see that now? Can you see that? 1, 2, 3, 4. Then the remaining 1 carbon atom to make it 5. Then you put it here in form of substituent as what? As methyl, as methyl. Some people call it methyl, but me, I usually call it methyl. Some call it methyl. That is methyl, which is a substituent. It's an alkyl group. Now, look at this methyl now. Please, because of time, note that hydrogen is here. There is hydrogen here. There is hydrogen here. But to make this video not too much, so I might be skipping the hydrogen. So please take note of that. There is hydrogen here. There is hydrogen here, here, and here. Please take note of that. So now look at this now. At least we are still obeying the definition of isomerism by saying what? It has 5 carbon, whereby the same molecular formula but different structure. This is one structure first. Now this is another look. It's another structure, as you can see. Yeah. But now let's name this thing. Let's name this thing. If we should name it, this has 5 carbon atom. 1, 2, 3, 4, 5. And it has what? 12 hydrogen atom of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Can you see that now? We are obeying the definition of isomerism. Don't forget that this particular one, the name is what? Pentane. Pentane. That's the first isomer of pentane itself. Now, this second one now, let's name it. If you have to name it, don't forget that the rule of naming organic compound, that is nomenclature, is by what? By observing your longest carbon atom, which is known as the parent chain. The longest chain, known as the parent chain. Now, what is the longest chain here? Let's look at the trend though. 1, 2, 3, 4, 5. Can you see? 1, 1, 2, 1, 2, 3, 4, 5. So that is the chain. Now, looking at this, and that's particular what? That is still pentane. That is still pentane. So I will not put my substituent, which is my methyl, I won't put it on the first carbon. Because if I put it on the first carbon, although the picture will change, fine, yes, but the naming will still be the same thing, the same thing with this. So that means I'm repeating the same thing, which is tautology. And tautology is not meant to occur here. So therefore, that means the second picture cannot be like this, because if I leave it like this, actually, I'm obeying the definition of isomerism, but the naming is still the same thing because I'm still drawing pentane. So therefore, this particular drawing is absolutely wrong. Now, what do I do next? I'm trying to show you this for you to get it very well so that you can determine the isomer of hexane yourself, of butane yourself, of heptane, octane, and others. Now, let me put 1, 2, 3, 4. Now, let me put this carbon, this substituent of CH3. Let me put it on the second carbon. Yes, on the second carbon. Please take note, like I said earlier, that hydrogen is here. All these carbons are carrying hydrogen. So, but because of time, I won't put the hydrogen so as to minimize our time. Now, look at this. Now, okay, fine. Let me name this now. If I should name this, don't forget the rule of naming. The longest carbon atom is what? 4. 1, 2, 3, 4. You can leave it like that, or 1, 2, 3, 4. You can see it's still 4. Look at the trend. 1, 2, 3, 4. That is still 4. 1, 2, 3, 4. Like this, straight is still 4. So that means the family name is what? But. That is butane. Because of what? It is what? It has 4 longest chain. 4 longest chain. So that's butane. Now, the substituent is what? The substituent is, it can be this and CH3. And if I like, don't forget that this particular hydrogen here is what? 1, 1, 2, 3. That is how many hydrogen? That is 3 hydrogen, which is also known as what? CH3. So, since it is CH3, my substituent can be here, and also my substituent can also be here, which is what? Methyl. So let me assume that I'm using this particular let me use this one as my substituent. Let me use this one, this CH3 here, as my substituent. Yes, as my substituent. So this is my substituent. Let me circle it. This is my substituent. That's my substituent. Let me circle it, which is CH3. Don't forget that this place too has how many hydrogen? 1, 2, 3. 1, 2, 3. Let me show it here. 1, 2, 3. Out of this place, 1, 2, and here 1. Why this place is my substituent? So now let me name this. Naming this will now be what? This is my carbon. This will be my no. On this carbon, I have my substituent attached to this carbon atom. I have my substituent attached to that carbon atom. Okay. So now, if I'm counting from here, this is my trend, this is my chain. If I'm counting from here or coming from here, which one is closer to the carbon atom carrying my substituent? It is from this place, as you can see, from the rules of naming organic compound. So from this place, counting from here is closer to the carbon atom carrying my substituent than coming from here. So if I should come from here, that means I'm coming from 1, 2, 3, 4. Can you see that? 1, 2, 3, 4. Now let's name this now. So naming this will now be 1, 2, or carbon 2. I have my what? Methyl. That's the substituent, methyl. So the naming of this will now be 2-methyl butane, because methyl is on carbon 2. Don't think that because I wrote CH3 here, this one is actually methyl. No. Most students usually make a mistake that whenever they see somewhere that they write CH3, they assume it is methyl. Though it is methyl. And at the same time, it might not be methyl or substituent or any other thing. If it doesn't goes together with the what? Sorry, if it goes with the longest chain, therefore it is not more methyl again. In naming organic compound, firstly, make sure that you determine your longest chain first. Make sure that the first thing that comes to your mind is for you to look for which trend is the longest, which chain is the longest. Sometimes your chain can be 1, 2, 3, 4, 5, 6, depending on how you are to name, depending on the structure you are given. So please take note. 1, 2, 3, 4. This one now is no more my substituent again. Then this one has now become my substituent. But if I want to take my that my longest chain is what? 4. If I want to take my longest chain like this, then it will be 1, 2, 3, 4. So this one will now turn to my substituent back. I hope you are following me. Please make sure you study this video very well and observe my points from this video. And please if actually you are getting something wrong in this place, or maybe you have something, a question to ask, please don't hesitate to just drop it in the comment section. Type it that, okay, this particular place, why is this place like this, why is this like this, can I do this, can I do that? Please, I'm expecting your question in the comment box. Now let's proceed. 1 2 3 4, I'm using this trend 1 2 3 4 because this is 1, this is 2, this is 3, this is 4. So the naming of this is now what? 2-methyl, because of carbon 2. This my substituent of methyl is attached to carbon 2. That is 2-methyl what? Butane. Let me write the name here. This is 2-methyl butane. So this is my second isomer. That's my second isomer. I hope you can see that very well. Please study that very well. That's my second isomer. Now, the next thing for me to do, don't forget that I put my CH3 here first. No, I first put it here in the first instance. So the naming still give me pentane. Then I run it off. The second time, I carry this CH3, I fix it here. When I fix it here, then you can see that the structure changes. The structure changes. Can you see that? So when I fix it here, the structure changes, and thank God the name also changed from pentane. That's why I can name it as my second isomer. Now what am I to do again? I am to still fix this particular CH3 here and put it here again. Then I'll fix it here. If I should fix it here, I don't want to write on this cardboard because of the space. If I should still fix it here, what is it going to give me? Now let's assume that in my next line, I don't want to waste this cardboard. So if I should still write CH3 here, now let's name it. Assuming I'm writing my next line now, CH3 is here. Now let's name it. The naming will now goes down. So, my carbon atom will still be 4. I can use a straight line of 4 to still be 4. I mean, my longest chain rather. My longest carbon atom, which is my parent chain, will still be 4. But my substituent is now here now. It's no more here. Hydrogen has replaced this place now. I'm talking of my next step, but I don't want to write it because of space. So my H will be here, while my CH3 will be in this particular place now. Now let us name it. The naming will now be, don't forget that I said why counting from the rules of naming of nomenclature. Why counting? You count from the carbon atom closest to the what? To the carbon carrying the substituent. This carbon is now carrying substituents now. This carbon now is now carrying the substituent CH3 methyl alkyl group. Is carrying the substituent now. So my counting, it will not come from here because here is far. Here will be 1 2 3. Can you see that? Here will be 1 2 3. So it's far. But counting from here will be the best. It will be very, very okay. So it will now be 1 2. Can you see that? 1 2. So my substituent is here in this spot. So it will now be what? 1 2. Which the naming will not be what? It will still be 2-methyl on carbon 1, carbon 2, 2-methyl butane. That means I'm still repeating the same thing here. That means I'm still repeating what? The same thing in this particular place. Now I've put my substitute, I've put CH3 here, I've put CH3 here, I've put it here. Then if I should put it here again, it will still give me what? It will still give me this, which is what? Still pentane. I hope you are getting what I'm trying to say. Please, if you don't understand anything in this process, you can just ask a question in the comment box. Just type it there. I'll reply to your message. I'll reply to it. Now this CH3 is here now. It will still give me what? Pentane. Now what am I to do next? The next thing for me to do now, don't forget that after writing this one first, the next step for me to do is to reduce the carbon atom to what? To 4. Then when I reduce it to 4, it gave me this. So reducing it to 4, I put this CH3 everywhere. I put it here, put it here, put it here, put it here. Then I put it in everything. So I determine my answer. Then after putting it there,